In Chapter 8, we learned to work with monomials, polynomials. In Chapter 8, we learned to work with polynomials, and we learned to add, subtract, multiply, and divide polynomials. Today we're going to learn another important operation with polynomials, and that's factoring. Now, factoring, you've heard the word factor before. That has to do with multiplication. So, as you see there, multiplication begins with two or more factors and finds the product. So you begin with factors, you multiply them together, find the product. Factoring, you're starting with a product and you're finding the factors that you had to give you that product. So we're going to be working a little bit backwards from our multiplication, what we did through Chapter 8 with the multiplication. So the first thing we're going to do is we're going to factor common monomials. And all that is finding a common factor in each of the terms. So that definition there, a common monomial factor is a monomial that is a factor of all the terms in a polynomial. So what we're going to do to factor these, we're going to figure out the common term, the common monomial, and we're going to factor that out. And so looking at this first one, we have this 8x minus 16. Now, do you see any common factors in there? Well, we see that 8 is a common factor because 8 goes into 8 and 8 goes into 16. And then we have an x squared in the first term, but no x's in the second term. So 8 is our common factor. So we put an 8 there. That's a factor. And then what we put inside the parentheses is what would we multiply by 8 to get our 8x squared minus 16. So 8 times what gives me 8x squared? Well, that would be x squared. And then we have a minus sign, and 8 times what gives me 16, and that's 2. And so that is factored. We can check this by multiplying it back out using our distributive property. So we could check, our check will be in red here. If we distribute, we get 8x squared. We have our minus sign, and then 8 times 2 is 16, and we get what we started with. Coming to the second one here, it's a trinomial because it has 3 terms, and we want to find a common monomial factor. So first we start with the coefficient. We have 3, 27, and 9, and we notice that 3 is common into all of those. Now look at variables. We have an x squared, so 2 factors of x, just an x and just an x. So the common one is just an x. We can't put x squared because the second and third term don't have an x squared. They only have x. And then we have a y in each of them, and a y to the first, a y to the first, and a y cubed. Well, the common one is just y. And now we're going to see what would we multiply by 3xy, our common monomial factor, to get our polynomial here. Well, 3xy times just an x, because we have our 3, we have an x squared, so we need an extra x to get to x squared, and we have a y, minus, and we want 3xy times what gives me 27xy. Well, there I just need a 9, because 9 times 3 is 27, and we already have the x and y. And then we have our plus sign, and 3xy times what gives me 9xy cubed. Well, 3 times 3 gives me the 9, so I need a 3 here. I have an x, and I have a y, but I have a y cubed here, so I need y squared. Again, I can check by multiplying this back out. 3xy times x is a 3x squared y. We have a minus, so 3 times 3 is 27. Then we just have the x and the y. And lastly, we have plus, 3 times 3 is 9. We have x and then a y squared gives y cubed, which does equal that original, so I factored correctly. So this part is my answer. Similarly to this over here was my answer. Some strategies or some steps we can do is find the greatest common factor of the terms. and then divide each term of the polynomial by the greatest common factor. That's what we were doing in those past examples. And then check our solutions by multiplying. So looking at these last couple examples, we want to find the GCF, the greatest common factor. Well, we can look at our constants first, 14 and 21. We know 7 goes into both of those. And then we have a cubed in our first one and an a in our second. So our common factor, our greatest common factor, we just need an a. And then what we're going to do is it says divide, and we have talked about this in a couple different ways. We could divide here, so 14 divided by 7 is 2. A cubed divided by a is a squared. We have our plus sign. 21 divided by 7 is 3. And a divided by a is just 1. Another way we talked through that, so that is our answer, and we'll get to the same thing in a minute, but we also can think through it this way and think 7a times what gives me 14a cubed, and that would be the 2a squared that we had earlier. And 7a times what gives me 21a? Well, that would just be 3. So that's factored. Looking at our last example here, we want to find common factors, the greatest common factor. As we look across the three of them, we see each of them have an x. The first one has an a, but the other two don't. And so that's our only common factor is x. And so let's think through it the way that I have written here. Divide each term of the polynomial by the greatest common factor. So x times a squared divided by x just gives me a squared. Plus xy divided by x is just y. And then minus x divided by x is 1. I see a lot of mistakes here. If there was an x here, some people just think it's 0, but x divided by x is 1. That is factoring the common monomial. And that's the first strategy that we'll use. And that's what you should always start with when factoring. First, you want to see if there's a common monomial factor.